Investigate the powers of I with the intention of trying to find a general rule for I to the n. So let's start with the most basic power, which is I to the power of 1. That is just I. I squared, we know, is equal to minus 1 by the definition of the fact that I is equal to the square root of negative 1. If we square that, we have to get negative 1. Now, I cubed is equal to I squared times I to the 1, using laws of indices, so it's got to be minus I. And I to the 4, well, I to the 4 is I squared squared, that's minus 1 squared, which is 1. I to the 5 is equal to I to the 4 times I to the 1. So that's 1 times I, which is I. I to the 6 is I to the 5 times I to the 1. That's I times I, that's I squared, which is minus 1. I to the 7 is equal to, well, we could do this in multiple ways, I to the 3 times I to the 4. But I to the 4 is equal to the 1, so that's just equal to I to the 3, which is minus I. And I to the 8 is equal to, what could we do? I to the 8 is equal to I to the 4 times I to the 4. But that's just I to the 4, which is 1. And what you might have noticed immediately here is that there's this repetitive pattern. So I to the 9 is going to be I to the 10 is going to be minus 1. I to the 11 is going to be minus I. And I to the 12 is going to be 1. And just carries on like this. Now, an interesting question would be to think, does this work if we go backwards? Does this pattern continue if we were to work backwards from here? Well, the row before this, the next one before I to the 1 would be I to the 0, which is indeed equal to 1. Then we would have I to the minus 1. I to the minus 1 is 1 over I. To rationalize that, we multiply by I over I, which is I over negative 1, which is indeed minus I. Works out like we would expect it to. Before that, we would have I to the minus 2. I to the minus 2 is 1 over I squared. But I squared we know is minus 1. So this is 1 over minus 1, which is minus 1. And I to the minus 3. A few ways we could think about this, but the easiest way is to think of it as 1 over I cubed. 1 over I cubed. Well, I cubed is minus I, so this is 1 over minus I. So that's equal to 1 over I is equal to minus I, so 1 over minus I has got to be equal to I. So yes, it does indeed work if we go backwards as well. It still works. So can we turn these into some general rules? Well, there's not a general rule for all of them. We have to come up with a general rule for each individual one of these 4 options. So we could have something like I to the 4n plus 1 is equal to I to the 4n plus 2 is equal to minus 1. I to the 4n plus 3 is equal to minus I. And I to the 4n plus 4, or just 4n, is equal to 1. What we do notice is that when the power is even if it's negative, we're going to get a real answer. And when the power is odd, we're going to get an I, an imaginary answer. Now these are useful because it enables us to do things when we have particularly large powers. So for example, if we have something like I to the power of 2012, all we need to do is think about how does this relate to a multiple of 4. So 2012 is actually 4 lots of 503, which means it's I to a multiple of 4, which means that's equal to 1. If it had been 1 more than a multiple of 4, it would have been I. If it had been 2 more than a multiple of 4, it would have been negative 1. 3 more than a multiple of 4, it would have been negative I. But knowing these rules, or at least being able to work them out quite quickly, enables us to deal with powers of I and simplify them down to either a 1 or a minus 1, or an I or a minus I.